According to the 2023 National Electrical Code, AFCI protection is mandatory for all 120-volt, 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit bedrooms. This requirement aims to enhance electrical safety by mitigating the risk of fires caused by arc faults, which are unintentional electrical discharges that can occur due to damaged or deteriorated wiring. Arc faults can generate intense heat and ignite surrounding materials, leading to potentially devastating fires. AFCI breakers are designed to detect these arc faults and quickly interrupt the circuit, preventing the fire from starting or spreading. In addition to the general requirement for bedroom circuits, the 2023 National Electrical Code also mandates AFCI protection for all 120-volt, 15 and 20 ampere branch circuits supplying smoke alarms or carbon monoxide alarms. This specific requirement is intended to ensure that these critical life safety devices are protected from arc faults, which could potentially disable them and leave occupants vulnerable to fire or carbon monoxide poisoning. Smoke alarms and carbon monoxide alarms play a vital role in early detection and warning, giving occupants valuable time to escape a hazardous situation. Therefore, it is crucial to maintain their functionality and reliability. If a bedroom has a smoke alarm circuit, that circuit must be protected by an AFCI breaker. This is because the smoke alarm circuit is supplying a device, the smoke alarm, that is installed in a dwelling unit bedroom. The code makes no distinction between general bedroom circuits and smoke alarm circuits when it comes to AFCI protection. Both types of circuits fall under the same requirement due to the potential fire hazards associated with arc faults. The National Electrical Code recognizes that smoke alarms are essential safety devices and, therefore, mandates additional safety measures such as AFCI protection to ensure their reliable operation. It is not a good idea to put the smoke alarm on its own circuit because if the AFCI breaker trips, it will also trip the smoke alarm circuit. This could leave the smoke alarm without power and unable to function properly. The primary concern with placing a smoke alarm on a dedicated circuit is the potential for a nuisance trip of the AFCI breaker, which could render the smoke alarm inoperable without the occupant's knowledge. AFCI breakers are designed to be sensitive to arc faults, and while this sensitivity is crucial for detecting and preventing fires, it can also lead to occasional false trips due to normal electrical activity or transient events in the circuit. If a smoke alarm is on a dedicated circuit and the AFCI breaker trips, the smoke alarm will lose power and cease to function, potentially compromising the safety of the occupants. To avoid this situation, it is generally recommended to connect smoke alarms to a general-purpose bedroom circuit that also serves other outlets or devices. This approach provides redundancy and ensures that the smoke alarm remains powered even if the AFCI breaker trips. However, it is important to note that the 2023 National Electrical Code requires AFCI protection for all 120-volt, 15 and 20 ampere branch circuits supplying smoke alarms, regardless of whether they are on a dedicated circuit or a general-purpose circuit. Therefore, even if the smoke alarm is connected to a general-purpose bedroom circuit, the circuit must still be protected by an AFCI breaker. In summary, the 2023 National Electrical Code requires AFCI protection for all 120-volt, 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit bedrooms, including smoke alarm circuits. While it is generally not recommended to place smoke alarms on dedicated circuits due to the potential for nuisance tripping, the code mandates AFCI protection for all smoke alarm circuits, regardless of the configuration. This comprehensive approach ensures that both general bedroom circuits and smoke alarm circuits are protected from arc faults, enhancing electrical safety and protecting occupants from fire hazards. To further elaborate on the technical aspects of AFCI breakers and their application in residential electrical systems, it is important to understand the different types of AFCI breakers and their specific functions. There are two main types of AFCI breakers: branch or combination AFCI breakers and outlet branch circuit AFCI breakers. Branch or combination AFCI breakers provide protection against both series arc faults and parallel arc faults. Series arc faults occur when there is a break in a single conductor, such as a loose connection or a damaged wire. Parallel arc faults occur when there is a short circuit between two conductors, such as a live wire and a neutral wire or ground wire. Branch or combination AFCI breakers are typically installed in the electrical panel and provide protection for the entire branch circuit. Outlet branch circuit AFCI breakers, on the other hand, provide protection only against parallel arc faults. These breakers are typically installed at the first outlet in the branch circuit and protect only the wiring and devices downstream from that outlet. The 2023 National Electrical Code requires the use of branch or combination AFCI breakers for all 120 volt, 15 and 20 ampere branch circuit supplying outlets or devices installed in dwelling unit bedrooms, including smoke alarm circuits. This requirement ensures comprehensive protection against both series and parallel arc faults, minimizing the risk of fires. When installing AFCI breakers, it is important to follow the manufacturer's instructions carefully. AFCI breakers are more sensitive than standard circuit breakers and may require special wiring techniques to prevent nuisance tripping. It is also important to test AFCI breakers regularly to ensure that they are functioning properly. AFCI breakers have a test button that can be used to simulate an arc fault and verify that the breaker trips as expected. In addition to AFCI protection, the 2023 National Electrical Code also requires ground fault circuit interrupter (GFCI) protection for certain outlets and dwelling units. GFCI protection is required for all 120 volt, 15 and 20 ampere receptacles installed in bathrooms, kitchens, garages, and outdoor areas. GFCI protection is designed to protect people from electrical shock by detecting ground faults and quickly interrupting the circuit. Ground faults occur when there is an unintended path for electricity to flow to ground, such as when a person comes into contact with a live wire and a grounded object. GFCI breakers are similar to AFCI breakers in that they are more sensitive than standard circuit breakers and may require special wiring techniques to prevent nuisance tripping. It is also important to test GFCI breakers regularly to ensure that they are functioning properly. The combination of AFCI and GFCI protection provides a comprehensive approach to electrical safety in dwelling units, minimizing the risk of fires and electrical shock. By understanding the requirements of the 2023 National Electrical Code and following proper installation and testing procedures, electricians and homeowners can ensure that their electrical systems are safe and reliable. Furthermore, to gain a deeper understanding of the interconnectedness of smoke alarms and the implications for AFCI protection, it's essential to delve into the different types of smoke alarm systems commonly used in residential settings. There are primarily two types: single-station smoke alarms and interconnected smoke alarm systems. Single-station smoke alarms are self-contained units that operate independently of each other. Each smoke alarm has its own smoke sensor, alarm horn, and power source, typically a battery or AC power with a battery backup. When a single-station smoke alarm detects smoke, it activates its own alarm horn, alerting occupants in the immediate vicinity. Interconnected smoke alarm systems, on the other hand, consist of multiple smoke alarms that are wired together so that when one smoke alarm detects smoke, all of the interconnected smoke alarms activate their alarm horns simultaneously. This interconnectedness provides a more comprehensive warning system, ensuring that occupants throughout the dwelling unit are alerted to the presence of smoke, regardless of their location. Interconnected smoke alarm systems can be wired together using either hardwired connections or wireless connections. Hardwired interconnected smoke alarm systems use low-voltage wiring to connect the smoke alarms together, while wireless interconnected smoke alarm systems use radio frequency signals to communicate between the smoke alarms. The 2023 National Electrical Code requires that all new dwelling units be equipped with interconnected smoke alarm systems. This requirement is intended to provide a higher level of fire safety by ensuring that all occupants are alerted to the presence of smoke, regardless of their location in the dwelling unit. When installing interconnected smoke alarm systems, it is important to follow the manufacturer's instructions carefully. Interconnected smoke alarms typically require a neutral wire connection in addition to the hot wire and ground wire connections. The neutral wire is used to provide a common reference point for the interconnected smoke alarms, ensuring that they operate properly. In addition to the wiring connections, it is also important to ensure that the interconnected smoke alarms are compatible with each other. Some interconnected smoke alarm systems require the use of specific models or brands of smoke alarms to ensure proper operation. When considering AFCI protection for interconnected smoke alarm systems, it is important to remember that the 2023 National Electrical Code requires AFCI protection for all 120-volt, 13 and 20 ampere branch circuits supplying smoke alarms, regardless of whether they are single station or interconnected. This means that if the interconnected smoke alarms are powered by a 120-volt, 15 or 20 ampere branch circuit, that circuit must be protected by an AFCI breaker. In the case of interconnected smoke alarm systems, the AFCI breaker will protect all of the smoke alarms connected to the circuit. If one of the smoke alarms detects an arc fault, the AFCI breaker will trip, interrupting the power to all of the smoke alarms on that circuit. While this may seem like a disadvantage, it is important to remember that the primary goal of AFCI protection is to prevent fires. By interrupting the power to the smoke alarms, the AFCI breaker can prevent a potential fire from starting or spreading. Furthermore, interconnected smoke alarm systems typically have a battery backup, which will allow the smoke alarms to continue operating even if the power is interrupted. The battery backup will provide temporary power to the smoke alarms, allowing them to continue detecting smoke and sounding the alarm. In summary, interconnected smoke alarm systems provide a more comprehensive warning system than single-station smoke alarms, ensuring that all occupants are alerted to the presence of smoke, regardless of their location in the dwelling unit. The 2023 National Electrical Code requires that all new dwelling units be equipped with interconnected smoke alarm systems. When considering AFCI protection for interconnected smoke alarm systems, it is important to remember that the code requires AFCI protection for all 120-volt, 15 and 20 ampere branch circuits supplying smoke alarms, regardless of whether they are single station or interconnected. This comprehensive approach ensures that both single-station and interconnected smoke alarm systems are protected from arc faults, enhancing fire safety and protecting occupants from fire hazards. Beyond the specific requirements for AFCI protection of smoke alarm circuits, it's valuable to discuss the broader context of electrical safety in residential settings and the importance of adhering to the National Electrical Code. The National Electrical Code, or National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association, and is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the safe installation of electrical systems in residential, commercial, and industrial buildings. Adherence to the National Electrical Code is essential for ensuring the safety of occupants and protecting property from fire and electrical hazards. Many states and local jurisdictions have adopted the National Electrical Code as law, making it mandatory to comply with its requirements. Even in jurisdictions where the National Electrical Code is not legally binding, it is still considered a best practice to follow its recommendations. The National Electrical Code is not a design manual, but rather a set of minimum safety requirements. It is the responsibility of qualified electricians and electrical engineers to design and install electrical systems that meet the specific needs of each building while also complying with the National Electrical Code. The National Electrical Code is organized into chapters, articles, and sections, making it easy to find specific requirements for different types of electrical installations. It also includes numerous tables and examples to help clarify the requirements. Some of the key areas covered by the National Electrical Code include wiring methods, which specify the types of wiring that are permitted for different applications and the methods for installing them safely. Overcurrent protection, which includes requirements for circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Grounding, which establishes requirements for grounding electrical systems to prevent electrical shock and ensure proper operation of overcurrent protection devices. Equipment installation, which covers the safe installation of electrical equipment, such as lighting fixtures, appliances, and motors. In addition to the National Electrical Code, there are other standards and regulations that may apply to electrical installations in residential settings. These may include local building codes, state electrical codes, and federal regulations. It is important to be familiar with all of the applicable standards and regulations before beginning any electrical work. Electrical work can be dangerous, and it is always recommended to hire a qualified electrician to perform any electrical work that you are not comfortable doing yourself. Qualified electricians have the training and experience necessary to install electrical systems safely and in compliance with all applicable codes and regulations. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. You should also ask for references and check their reputation before hiring them. In addition to hiring a qualified electrician, there are several things that you can do to ensure the safety of your electrical system. These include regularly inspecting your electrical system for any signs of damage or wear, replacing any damage to worn wiring or equipment, and avoiding overloading electrical circuits. You should also never attempt to repair electrical equipment yourself unless you are qualified to do so. Electrical safety is a shared responsibility, and it is important for both electricians and homeowners to take steps to ensure the safety of electrical systems. By following the requirements of the National Electrical Code and taking other precautions, we can minimize the risk of fires and electrical hazards and protect ourselves and our families from harm. Also, it is worth addressing the potential impact of AFCI breakers on older homes and the considerations that may arise when retrofitting these devices into existing electrical systems. While the National Electrical Code mandates AFCI protection in new construction and renovations, the decision to install AFCI breakers in older homes that predate the code requirements is often left to the homeowner. There are several factors to consider when deciding whether to retrofit AFCI breakers into an older home. The first factor is the condition of the existing wiring. Older homes often have outdated wiring systems that may not be compatible with AFCI breakers. For example, older homes may have ungrounded wiring systems, which can cause AFCI breakers to nuisance trip. It is important to have a qualified electrician inspect the existing wiring system to determine whether it is suitable for AFCI breakers. The second factor to consider is the cost of the retrofit. Retrofitting AFCI breakers into an older home can be a significant expense, as it may require replacing existing circuit breakers and possibly upgrading the wiring system. The cost will vary depending on the size of the home and the condition of the existing wiring. The third factor to consider is the potential for nuisance tripping. AFCI breakers are more sensitive than standard circuit breakers and may be more prone to nuisance tripping in older homes with outdated wiring systems. Nuisance tripping can be annoying and inconvenient, and it may require troubleshooting by a qualified electrician. Despite these considerations, there are also several benefits to retrofitting AFCI breakers into an older home. AFCI breakers can provide enhanced protection against electrical fires, which are a leading cause of property damage and injuries. They can also help to protect against electrical shock by detecting ground faults. In addition, retrofitting AFCI breakers can bring an older home up to code, which may be required for insurance purposes or when selling the home. If you are considering retrofitting AFCI breakers into an older home, it is important to consult with a qualified electrician to determine whether it is the right decision for you. The electrician can assess the condition of the existing wiring system, provide a cost estimate, and advise you on the potential benefits and drawbacks of the retrofit. It is also important to choose the right type of AFCI breaker for your specific application. As mentioned earlier, there are two main types of AFCI breakers: branch or combination AFCI breakers and outlet branch circuit AFCI breakers. Branch or combination AFCI breakers provide protection against both series arc faults and parallel arc faults, while outlet branch circuit AFCI breakers provide protection only against parallel arc faults. The 2023 National Electrical Code requires the use of branch or combination AFCI breakers for most residential applications. When retrofitting AFCI breakers into an older home, it is also important to ensure that the breakers are properly labelled. A national electrical code requires that all circuit breakers be clearly labelled to indicate the circuits that they protect. This is important for safety reasons, as it allows homeowners to quickly identify and shut off the power to a circuit in the event of an emergency. In summary, retrofitting AFCI breakers into an older home can be a beneficial safety upgrade, but it is important to consider the condition of the existing wiring system, the cost of the retrofit, and the potential for nuisance trapping. Consulting with a qualified electrician is essential to determine whether a retrofit is appropriate and to ensure that the AFCI breakers are properly installed and labelled.